Hello and Assalamu alaikum guys. In this particular video, we're going to be talking about scalar quantities and vector quantities, and we will also be discussing vector addition and vector subtraction. The first thing you need to identify is that the difference between scalar quantities and vector quantities is that scalar quantities are those physical quantities which do not contain direction. So there is no direction associated with the scalar quantities. And also, they cannot be added by the methods of vector addition. Whereas vector quantities are those quantities which have both magnitude, direction, and also unit. So that's the major difference. Scalar quantities have magnitude and unit, whereas vector quantities have magnitude, just like scalar quantities. They have unit, just like scalar quantities, but they also have direction associated with them. So if there is a direction associated with any quantity, then that quantity is going to be called vector quantity. I would not suggest you to figure quantities out in examination, that whether they are scalar quantities or vector quantities. Instead, it's going to be better if you learn. Because for many quantities, you might be confused. Like, if, for instance, if you look at pressure, and you'll see that pressure is force upon area. So you might be feeling that since F is a vector quantity, so probably pressure might be a vector quantity as well, but it is not. Similarly, if you look at work and you identify work as the product of force and displacement, where force and displacement both are vector quantities, then you might probably think that it is a vector quantity, but actually it is not a vector quantity. Likewise, you look at current and you talk about circuits, and you know that current flows in a particular direction. So you see that the current it flows from positive end to negative end. So you might think that it is a vector quantity, but it is not that direction that we associate with vectors, because this up direction is same as this right direction, and that is also same as this down direction. So it's the same direction. So it's just like a loop of circuits. So it's not that direction that we associate with vectors. Similarly, you know that a lot of times you say that vector quantities are positive for one direction and negative for the other direction. Well, voltage is also positive and negative, but it is not a vector quantity. My point is that I don't want you to learn that I don't want you to figure out in exam that this is a scalar quantity and this is a vector quantity. Instead, it would be a good idea if you remember this list, that which quantity is vector quantity and which quantity is scalar quantity. So in two-dimensional plane, like a flat surface, you represent vectors by means of an arrow or a directed line segment. So what you do is that you draw a line segment, an arrow whose length is the representative of the magnitude of the vector quantity, and whose arrowhead is representative of the direction of that vector quantity. So whatever vector quantity you have to represent, you're going to decide a scale upon that. Like, for example, if I have to draw a velocity of 25 meters per second, so I'm going to have to decide an appropriate scale. So if I take 5 meters per second as 1 centimeter, then 25 meters per second would be equal to 5 centimeter. And that's like an appropriate scale to draw. I'm going to pick out my ruler and draw a 5 centimeter long line. In what direction? The head should point in the direction of vector. So if it's pointing towards north, so we all know that this is north direction, this is east, this is west, and this is south. So that's how I can figure that out. I had to represent two 10 Newton forces. And by the way, if you are ever told an angle of the vector, that forms always at the tail. So if in any situation you are being given an angle, you would be given at the tail. If in any situation you're being asked an angle, so you would also tell it at the tail. So there are two 10 Newton forces. 1 towards east, so that's rightwards, and north 60-degree east, so this is north, this is east. From north I go 60-degree down, and I can measure an angle of 60 degrees and then draw two lines. Now, and then obviously I'd have some sort of scale being decided for that as well. So if I have to draw 10 Newton, an appropriate scale might be 2 Newton equals 1 centimeter, so that 10 Newton would be equal to 5 centimeter. And I can draw my line segment 5 centimeter long here, 60 degrees from the north towards east, and another 5 centimeter long line segment towards right, which is representing the east direction. So guys, this is how I represent vector quantities. The only issue with vector quantities is that their addition is not as straightforward as the addition of scalar. So every time I have to add 5 kg and I have to add 3 kg with that, I will always get my answer as 8 kg because this is a scalar quantity. But a 5 Newton added to 3 Newton can give me a range of possible answers because it depends on direction. If 5 Newton and 3 Newton are acting in the same direction, it will give me 8 Newton. But if 5 Newton and 3 Newton are acting in the opposite direction, it will give me 2 Newton. And then obviously, depending on their orientations, their directions, the magnitude of the resultant would keep on varying. So, and every time you have to add vectors, you have to apply the head to tail rule. So the two vectors that you have to add, and the order does not matter. It's a commutative addition. So you do A plus B or you do B plus A, you're going to get the same result. But you have to apply head to tail rule of vector addition. So you pick one vector, you draw A as it is. But when you draw B, you have to draw B in such a way that the tail of B, without changing the orientation of B, the length of B, you have to redraw B onto the head of A, so that the tail of B lies on the head of A. And once you do that, you've drawn vector A, you've drawn vector B, you find out the resultant vector by joining the tail of A to the head of B, and that gets you the resultant. So in O level, you are supposed to be doing scaled diagrams. So once you've drawn A plus B, to find its angle, you can measure the angle with protector at the tail. And to find the magnitude, you can find out the length of A plus B by using a scale ruler. Now, once you do this, you draw the head of second vector, and it doesn't matter what you take as a second vector. So you could also have done B first, then A, and you could still have drawn A plus B the same way. You still get the same answer. But if you've gotten yourself A plus B, then this particular method where you draw the tail of second vector onto the head of the first vector and then draw the resultant, then this is also called triangle law of vector addition. This head to tail rule method in this specific situation is also called triangle law of vector addition, because the diagram that you get by putting head of second vector onto the tail of first vector is basically a triangle. But in many situations, you have to add two vectors which are originally having their tails together. Many a times you'd come across this kind of a situation. So if you have to add two vectors whose tails are together with each other, then to find out the resultant of such two vectors, you have a choice. Either you draw a triangle again, that is, you draw A again and B again and then complete a triangle, so that you do have that choice. But what you could also do is that opposite to A, you draw another A vector, and opposite to B, you draw another equal B vector, and complete the figure as a parallelogram. The diagonal of that parallelogram basically represents the resultant vector. From the tails of the two vectors, it's very important that you draw the direction correctly. So resultant, be it triangle law of vector addition or parallelogram law of vector addition, the resultant is always going to be drawn from the tail to the head. And that's how you would get the resultant. That's how you get the resultant of the parallelogram law. Now, similarly, though this is not asked too often in O-level, but it's good to know that you can also subtract two vectors. And there are various ways of doing that. One is that to subtract and find A minus B, you could do A plus minus of B. That is, you add a negative B vector onto vector A. So with the same vectors, you draw B's negative vector, which is same magnitude but opposite direction, and on A vector, by using head to tail rule, you can add a negative B vector. And what you get as a resultant from tail to head is A minus B. Alternatively, you can also get resultant by drawing, just like in addition, you have to make sure that head connects with the tail. In subtraction, you can connect two tails together, or you can connect two heads together. Keeping in mind that if you choose to connect two tails, the two vectors that you're subtracting, if you're connecting their tails, then the difference vector should point towards the first vector. If I want to find out A minus B, my difference vector should point towards A. If I want to find B minus A, my difference vector should have pointed towards B. Since I'm finding A minus B, so its orientation is towards A. Opposite happens if you're joining heads together. So if you have to subtract and you put the two heads together, then the difference vector is going to be pointing towards the second vector, like B over here, in case if you're joining two heads together. So in simple words, if you're adding two vectors, you have to connect head with tail. When you're subtracting two vectors, either you can add a negative of the second vector, or you can connect two tails together or two heads together, and you can get yourself the difference vector. Now, let's have a look at some questions that you would get. Like in this particular question, it says when two forces are combined, the resultant depends on the angle. So we do know that, right? So if I have one vector like this, and another vector in the same direction, the angle is 0, I get a larger resultant. If I have one vector like this, and I have another vector pointing in the opposite direction, I'll get the smallest possible resultant. But they can be in different orientations. They can be in different angles, and I can have different sizes of resultant. So when I'm finding out the resultant, the magnitude depends upon the direction. I do know that. So it says what cannot be the magnitude of the resultant force. So if you're adding 3 Newton and 4 Newton, if they act in the same direction, they should give me 7. And if they act, and this is the largest possible magnitude, and if they act in the opposite direction, then they should give me 1 Newton. That is 4 minus 3. So this is the minimum possible magnitude. So I can have resultant force anything between 1 and 7. It cannot be smaller than 1. It cannot be larger than 7. So when it says cannot be the magnitude, so I know that 8 Newton cannot be the magnitude of resultant force. And you also get questions like this where it says, which of the following groups of physical quantities consists only of scalars? So you can identify which quantities are only scalars. So you know that acceleration is a vector quantity. I can't list this. Acceleration is again a vector quantity. Even force and velocities are vector. So that's the A and B are not my option. Here I have force and velocities as vectors, so they are not my option. Mass, speed, and time. So this is entirely learning based. You have to remember which quantity is a scalar and which quantity is vector. Then says which diagram correctly shows the addition of a 4 Newton and a 3 Newton force. So we're talking about addition. 4 Newton and 3 Newton must be connected in such a way that one head connects with the other tail. So if you see 4 Newton's head in option A is connected with 3 Newton tail, that's fine with me. This is also 4 Newton with 3 Newton. That is also fine with me. But this is not fine because two tails are connecting, and that is something I could do for subtraction but not for addition. And also D is not an option because when two heads are connecting, I don't get addition. So my choices come down to A and B. But then if I have to find the resultant, I know resultant goes all the way from tail to head. So this is how the resultant is going to be like, from tail to head. And hence, my answer is going to be A. Moving on, it says force of 3 Newton and 4 Newton are shown in the diagram. And then again, we have to find resultant. But there are two tails together. So if there are two tails together, and I have to get the resultant, I'm going to have to make sure that I complete a parallelogram. And when I complete a parallelogram, I could see that the resultant goes from tails to heads like this. So which diagram shows a possible resultant, I can tally it with the resultant that I've drawn, and that only matches with option A. This is how I pick my choice. Similarly, for this particular question, I will pick my ruler and I just measured y over here. Right now, it shows me a length of approximately 4 centimeter. So opposite to x, I make another 4 centimeter. And then I see that the resultant by using parallelogram law could only be option B. So I can figure out that for this one, the answer is B. I also get some structured questions, like in this question, if you would see, a microphone has a weight of 6 Newton. So I know that weight of the microphone must be acting vertically downward. So that is 6.0 Newton. And suspended by wire X from the ceiling. So I can see this wire is connected to the ceiling. And another horizontal wire Y. The tension T in wire Y is 8 Newton. So I also know this 8 Newton force. The horizontal, this force is 8 Newton force, I know that. And then it says use a vector diagram to determine the magnitude of the resultant of W and T. So guys, what I'm going to do is that I'm going to first of all decide a scale. I'd say that 1 Newton equals 1 centimeter. And to find the resultant of these two vectors, I'm going to make a horizontal line of length 8 centimeter. And I'm going to draw a vertical line on the head of it, which is going to be 6 centimeter long. It would be better if I can measure this angle as 90 degree using protector. Right now I don't have protector available. Then I will just draw this resultant, and according to the diagram that I made, it's not a very accurately drawn diagram, but I'm getting something around 10 Newton. I can cross-verify this by using some math rules. I know that if this is 8 Newton and this is 6 Newton and they are at 90 degrees to each other, then hypotenuse can be found out by using Pythagoras theorem. So I do 8 square plus 6 square actually gives me exactly 10. So that means my answer is fine. So that would be 10 Newton. I don't have protector available, but I measured this angle and I can tell the direction with the angle over here. So after that, it says that the microphone is set at rest, state the tension in wire X. So it uses some of the concepts of equilibrium, that if it is at rest, then the resultant of these two forces must be equal to this force. So the tension in wire X must be equal to the resultant of these two, which is something we've already found out as 10 Newton. So the tension in wire X could directly be found out as 10 Newton. Thank you guys. Please, if you found the video helpful, please do like the video and do subscribe to my channel.